Hi everyone, this video is on exercise 99 question 1 part C and F of pure 2. So in this question we should find the intervals on which the following functions are first convex and then concave. And as a quick recap, a function is concave if its second derivative is less than or equal to 0, and it's convex if it's greater than 0, greater or equal to 0. So obviously the first step of solving such questions is finding the second derivative, and then we can solve the inequalities to find the answers. Now in this video I'm going to do E and F because I've done the previous ones and the other videos. Okay, so for part E we have the function e to the x minus x squared. Let's find the second derivative. F dash x is equal to e to the x minus 2x, and the second derivative is e to the x minus 2. Now that we have the second derivative, for part I, we want to show or find when the function is convex. So in order to show when the function is convex, we solve this inequality that f double dash x is greater or equal to 0. So that means e to the x minus 2 greater or equal to 0. And we are going to get e to the x is greater or equal to 2. Then we can take the natural log of both sides to get x is greater or equal to the natural log of 2. And this is basically the interval, and we can write this as the interval then to positive infinity. So this is the interval for which the function f of x is convex. So for the second part, which is finding the interval when the function is concave, we find when f double dash x is less than or equal to 0. Now in this case, it's going to be very similar. So there's nothing really maybe interesting here, other than the fact that the inequalities are slightly different. So e to the x minus 2 is less than or equal to 0. Then we are going to have e to the x is less than or equal to 2, which means that taking the natural log of both sides, x is less than or equal to ln 2. And this can be written as this time minus infinity to ln 2. And that's the interval for which the function is concave. Right, for part F, we have the function f of x, which is equal to ln x. And obviously the values of x is always greater than 0. The domain of ln x is always x is greater than 0. So, and even if you're not given that in the question, you're expected to know this fact because it's very, very important. Because ln can't take values of negative or even 0. That's very crucial. Okay, again for parts, before solving parts 1 and 2, we first need to find a second derivative of f of x. So the first derivative, the derivative of ln x is 1 over x, and the derivative of 1 over x is going to be minus 1 over x squared. So this is the second derivative. Now we can solve the first part, which is finding the interval for which the function is convex. Again, in order to be convex, f double dash x has to be greater or equal to 0, which means minus 1 over x squared is greater or equal to 0. And as you can see, I will immediately have a contradiction, because minus 1 over x squared is always negative for all values of x. So since it's always negative, it can't be greater or equal to 0, which means, because of the contradiction, this simply means that this function is never convex. So it's not convex anywhere. You can write that f of x isn't convex. So yeah, it's very important to note that. So that's the first part. Now the second part is checking for when the function is concave. So we check for when f double dash x is less than or equal to 0, which means minus 1 over x squared is less than or equal to 0. And this one is interesting, which is the opposite case to what we had in the previous part. And that's because this time, for all the values of x, this function is always less than or equal to 0, right? Because no matter what value of x you give to the denominator, it's always positive. The denominator is always positive, but you have this negative here. So because of this negative here, your final number is going to be negative, and that a negative number is always less than to 0. So less than 0. So that means this function, the function is always the function is concave for all the values of x. By the way, all the values of x for ln x are x is greater than 0. So if you want to write the interval, you can write this as the interval for which the function is concave is the interval 0 to positive infinity. So any number in this interval it leads to a concave function. So the most important thing to remember in solving questions like this is that is always, thinking about the function itself and its behavior, as well as the domain and the possible values of x. Because by considering these, you can easily solve these questions and get the marks. Okay, that's it for this video, and thank you for watching.